G'day there, everyone at SANTFA. Thanks for the invitation to come and talk. Graeme Anderson from DEDJTR in Agriculture, Victoria. I've grew up on a farm, been working in agriculture R&D for the last 26 years, and the last 10, 12 years have been spending a fair bit of time with some of our climate scientists. So I know farmers are fascinated with the weather, so what I'm going to share with you today is just some of the penny drop moments for me in really better understanding what drives good old-fashioned variability and all about our weather and what's normal, what isn't, and what might be next. Now, one of the best comments I heard recently was a farmer saying, a good seasonal forecast is a bit like getting the latest minutes of the Reserve Bank board meeting. And, Glenn Stevens there is getting lots of economic data from across the economy and basically provides a little update and a bit of a snippet saying that, the next movement in interest rates will be, either up or down, or there won't be any movement. And really, I think it's a really good way to look at seasonal forecasts. So seasonal forecasts, when we're talking about, the 1 month to 3 month and longer term outlook, that's really as good as they are. There's a lot of great science looking at what's happening in oceans and atmospheres, and knowing which parts of Australia get affected by what, and saying that I think keep an eye out. There's might be a little bit of upside or might be a little bit of downside risk. So that's a really good analogy and way to think about these forecasts. One thing too, it's really interesting, I think, from a farming point of view, whether it's animal health issue. You think if you got a problem there, you're on the phone straight away to your vet, and you'll get the latest agricultural science sort of to diagnose and develop a solution. And the same too with your grain marketing or all of that. You're sort of getting that expert advice. But when it comes to something like climate and seasonal forecasts, really, I like to ask farmers, where do you get your information from? And while there is some good stuff in the media, sometimes it's not the most accurate place to get that. So one of the things I think in agriculture is just making sure for your particular area you're tapping into some good reliable commentary on what's actually happening. And I guess I know for farmers, if they're going to take any information into account to change decisions on the farm or how they're going to play out the season, there's a few things you're needing. Needing a trusted scientific source, so it's a good source. That it's actually relevant for your particular part of Australia, your particular region. And it's in language you understand, and it's not just one view, but it actually provides a bit of a balanced view of how others are reading this situation, and that you get this commentary behind the forecast. So not just commentary to say that, we think there might be a bit of a dry spring ahead. It's actually some discussion as to why we're thinking that, and I think that's really important. And we all learn 1 year at a time, but a key thing is just learning from one season to the next about what happened when, and what was a particular climate driver that pushed us in one direction or the other. So they're really important things, I guess, to try and it's part of what I call just improving our climate literacy. Now, as I travel around and speak to farmers, they tell me there's some key things they want, and one of them is better forecasts. And I guess the good news is forecasts are getting better. Computers are getting bigger. The amount of data collected out there in our atmosphere and oceans is, unprecedented. The satellite data and Argo floats, it's just amazing what's going on out there. But also is our understanding of which areas of ocean and what they're doing and how they affect different parts of Australia's rainfall. That's all getting better. And even down to the forecast, like in the 80s, a 3-day forecast was pretty good, but now we've got the 7-day forecast, and in coming years we look forward to sort of some 7 to 10 day and multi-week forecasts as well. So that's all coming. That's really good. But also one of the other things is that it's important that we do enough of our own homework to understand what the forecasts are saying and what they aren't saying. And that's sort of back to climate literacy, which is something that I think pretty pleased that farmers are really starting to skill up in this area and know what to look for and when. And I guess one of the things that no matter how good forecasts are, that they can only go so far. They're really like a good 5 or 10%er. And farmers who manage variability really well, they just say, listen, we've got to focus on the stuff that's under our control. It's good to get a heads up about forecasts, but in the end, it's about the decisions we make and what tactics, tools, and decisions we make to manage that variability from year to year. And that's under the direct control of farmers. So they're all the things that go together to manage seasonal variability. And I guess one of the sort of things about improving communication of forecasts is a bit of work that's going on at the moment, and one of the projects I'm involved with the new project through RURDIC and the Managing Climate Variability, which is teaming up with Birchup Cropping Group and South Australia people like Peter Heyman and Chris Sanderson, all the crew, and New South and Queensland and other agencies and the Bureau with the modelling to really try and improve some of the way we communicate and get some of this good stuff out to farmers. So we're just going to start here with a quick 101 on what makes rainfall. And basically to make rainfall, this is where it rained last year across Australia, and you can see these sort of colours are where it got more than 600 mil, more than 900 mil. And you'll notice that, a lot of it around the edges and up the top. But what are the key ingredients for making rainfall? Well, one of them is you've got to have a source of moisture. You can't sort of get rain out of dry air, so you've got to have a good source of moisture. And that's not all though. Something else has to happen, and meteorologists sort of tell us if all you had was moist air, it's just going to be humid. So something's got to happen to that moist air for it to fall out as rain. And basically what that is, it's got to get cold. So if you see moist air coming in and it hits the dividing range, as that air gets lifted up, as you go up, things get colder, so that moist air gets lifted up over the mountain, and then at a certain point it just drops its moisture as rain. And so as moist air gets cold, it drops out its rain. So interesting though, on the other side of the mountain range, as air is coming down off the mountain, it sinks, and as it's coming down, it sinks, it gets warmer, and warmer air can actually hold more moisture. So that's what's really explains a lot of that rain shadow effect. And what's important down south here for southern Australia and where we are, that we've got all these cold fronts that whiz along, and those sort of weather events down south are a really important trigger where there's a combination of cooler air and when it teams up with some good moisture, then we get some good rain. Now what this is just basically last year's rainfall again, but it's actually on a decile map. So just to explain deciles, this is showing that where last year's rainfall was the equivalent of being in a decile 1, or the driest 10% of years compared to that place's longer term record. And a decile 10 is where last year the places that got rainfall, where that rainfall would put it in the wettest 10% of years for the last 100 years or so. So you can see quite a bit of variation. There's always somewhere in Australia getting rainfall and somewhere that's missing out. If you can see here though, southern South Australia and Western Vic, decile 1. But interesting, you don't have to go very far to get some places that were decile 10. And I think what was interesting with last year is that, while we had the El Nino happening, there was actually still moisture coming out of parts of the Indian Ocean, and that was good. And it really came down to a couple of key weather events, and that made the difference between the haves and have-nots. You can see a lot of farmers in New South Wales had a great season, but yet some down south, had found it really tough. And go back a couple of years, 2010 and 11 was pretty wet. Most of the country, the decile 10 or wettest on record, and the Bureau sort of have that 2-year period down as the wettest 2-year period in our history, just pipped 74-75. So it's interesting, I speak to quite a few farmers who tell me that, our wet years are to do with when lake air is full. But I guess I ask them, so do you think there's enough moisture in lake air to provide that much moisture over the whole of the continent? And so the key question is, where did all that moisture come from? And we'll talk about that in a tick. But even including those couple of wet years, if you go back to 1997, a lot of farmers note that a few things have been a little bit different since then. But you can sort of see in that sort of period, while a lot of Northern Australia's probably had a wetter period, and a lot of WA has, and you know, places like if you head down to Esperance have had a pretty good time, but there's been other parts of Southern Australia that have just probably batting a bit below the average in terms of longer term rainfall. So we'll talk a little bit about why that was happening too. Now here's a good long-term rainfall record from Gawler, so some great number crunching from my colleague Dale Gray, and this is an anomaly map. Basically goes back to 1861 all the way through to last year, and this line is just a line through the long-term average, which is 459 millimetres. But you can see those really wet years that are in the record up to almost 800 mil, and quite dry years, you know, the 67 drought there down to just over 200, and so you can see that great variation there. And the key question is, what's the difference between one of these years and one of these years? And I guess when I look at, if you look at that long-term record, you know, what do you notice? Well, one thing, how often do you get average? Average rainfall doesn't happen that often. And also interesting, just a few periods where, you know, you had a drier run there in the 30s and a drier run there, looks like in the 80s. Here there's been a couple of dry years, but actually in terms of finishes, I would say, you know, Gawler's probably done pretty well, got a few years there above the line. And certainly when I look at a lot of the other rainfall zones in parts of Southern Australia, sometimes they haven't had as many above the line as that. So that's not a bad run there. Just looking here at that Gawler long-term record again, but here's just looking at that autumn rainfall, March, April, May. And again, see some big variations there from year to year. And probably, you know, you're just noticing a bit of this where there's a bit of a run of autumns there, probably, you know, in the 90s it hasn't been as good as what it has. There's a couple there in the last sort of 6-7 years which have been alright, so that's all good. But across a lot of southeastern Australia we're seeing a bit of this where autumns perhaps not quite as reliable as they once were. And here's spring rainfall from that long-term Gawler record again. You can see spring, you know, up and down, big variations there. But you know, those last few springs, you've actually had a run of pretty ordinary springs there by the looks, and there looks to be a few more of those dry springs in that last decade there. So that's something we'll have to keep an eye on. Now this variability, where does all this stuff come from? And I guess this is sort of one of my favourite pictures. It's here's Antarctica, viewing the planet from the bottom up, I guess, and the wetter and drier years here are all to do with these big climate drivers. And this one out here, the Pacific Ocean, the El Nino Southern Oscillation, such a really key player. And you know, to make rainfall down here, we're needing a good flow of tropical moist air that comes from these warm oceans to our north, and they sort of feed into the weather events. So we can have weather events coming along the south here, but if there's not much moisture coming from either of those oceans, they tend to be dry years, and especially that correlation strongest for that sort of late winter spring period. So out here in the Pacific, the trade winds blow towards Australia and they bring, you know, warm moist air. When we have an El Nino year, the trade winds actually head the other way, and you know, there's more rainfall out in the central and out in the South American side, so that basically cuts off that supply of moisture. It's not as reliable in those years as what we'd like. Over here, the Indian Ocean Dipole, it's really key influencer again of that flow of moisture down into the rainfall events down in southeast Australia. So both of these are key to watch, and when they hit that cold air, and you can see the fronts that all queue up, there's really strong winds in southern annular mode down south here, flicks their tails across southern Australia, and they're really important. And where that moisture meets up with the frontal activity, it's where we get some good reliable rainfall. Interesting, you look at years like 2006, we had an El Nino in the Pacific, so you know, it wasn't behaving, moisture was sort of restricted, and the same year Indian Ocean was in its drier phase. So when they're both in their drier phase, that's not helpful for making good rainfall conditions. And last year it was quite interesting, they both nudged into their drier phase, but last year was a big wrestle between an El Nino out here, which was misbehaving for us, but parts of the Indian Ocean were still providing some moisture supply, so that kept us in the hunt. But then later in the spring, the Indian Ocean just decided not to play ball. In that spring of 2010, we had a big La Nina, so it was pouring in moisture, and the Indian Ocean Dipole was also pouring in plenty of moisture. So weather events that year just had moisture coming from all directions. It was just a matter of over whose farm did the weather event go. So they're really important drivers for that sort of winter-spring periods. And I guess we sort of made the story up that they're about, these are the sheepdogs. These climate drivers are like the sheepdogs that round up our weather, and sometimes they're behaving and sometimes they're not. So we'll be having some, we'll add some links to these climate dogs on the website, so you can, and they're basically a quick 90-second summary of the science of how each of these climate drivers works. And sometimes these dogs behave and sometimes they misbehave. Okay, so what we're going to look at here is this is sea surface temperature anomaly maps, and this is what a dry pattern looks like, but this is part of that climate literacy where we're seeing increasingly more farmers are learning how to read this, and again it's something that's pretty important from our winter and spring period for how things are shaping up. Now, those oceans here along the equator are obviously a lot warmer than the ones down here. It's freezing down here, really warm up here. So what this is an anomaly map, and it's showing, these colours are where an area of the ocean is 2 degrees warmer than normal, and these colours are where an area of ocean's surface is 2 degrees cooler than normal. So you can see here back in September 2006 we've got an El Nino in the Pacific, and so the warmer water is really where you're generating most of the moisture, lots of cloud, and actually what happens is it tends to even pull the trade winds backwards. So and that sets up a bit of a higher pressure over Australia, and it's just very hard to get moisture coming our way. And if you look at these oceans to Australia's immediate north, these are all cooler than average. So when those oceans are cooler than average, they're not generating as much moisture as over here. So the Indian Ocean dipole and the Pacific, both of them were misbehaving that year, and that's one of those patterns that we don't tend to want to see when we're in sort of July onwards, because it means that those weather events we have down south, they're trying to tap into a good source of moisture, but these oceans aren't really generating as much. All the action's happening somewhere else. Now I want you to have a look at this particular area to the north and watch it and just see if you notice any changes when we'll compare with, say, the spring of 2010. So just see if you notice any difference in the sea surface temperature change. Rightio, there we go. So 2010, this is what a wetter pattern looks like, October 2010, big La Nina, and you can see here these oceans were, they were basically at record temperatures, so we had really warm oceans up north, heaps of moisture and cloud being generated, and basically any weather events down this part of the world had moisture to draw in from wherever it wanted. And really it was about, where did the cold air and the moisture most collide for who got the biggest events. So that's pretty well, that's the wetter pattern and the dry pattern, and usually our seasons are somewhere in between those two, but it's one of those little tools to keep an eye on to work out how's each season shape up. Now what we're going to do with the Gawler record, and you can do this with any, but Dale Gray, again, colleagues crunched some numbers, and if you put the driest year, the second driest year, third driest year, and you line up all of those years from driest through to the wettest, you can end up with what we call terciles. So there's the wettest third of years, the average years, and then the driest third of years. And longer term, we had a third are in each. That's basically how it works. But what we're going to look at is we're going to go back through and look at previous El Nino events and Indian Ocean dipole events and see how did it change some of that August to October rainfall at Gawler. So here we go. This is El Nino years, and in that's a sort of pattern of where there's drier years, decile 3 sort of years. When we look at Gawler's rainfall, those 33 El Nino events, rather than just a third of those being dry in decile 1 to 3, actually 2 out of 3 of those years. So it doubles the chance of a dry year when you're looking at the effect of El Ninos at Gawler. You can still see, though, that interesting, a third of years were either average or okay. So that just means that, 1 or 2 decent weather events that can tap into some moisture even in an El Nino year can make the difference. And we saw a bit of that last year. So El Nino doesn't guarantee a dry spring, but it does increase the chances. La Nina years, more moisture, probably tends to be a bit more further north in terms of who benefits. We probably don't benefit as much down here as we'd like, and I'm not sure who you complain to about that. It's just the way it is. But as you see there, there's probably a fraction bit wetter, but there's still dries, plenty of dries and averages in there too. Now here we go, here's Gawler's rainfall. Dale Gray's kindly printed these off. This is the El Nino years, you can see there. And Dale's just printed off those dry years. This is the August to October rainfall years. And you can see that more of them are in that decile 1 to 3 colour. than in the average, but there was some that were wet. And you can see some of these different finishes, how they went, but last year, 2015, was sort of down here. And I think one of the key things, if you look at last year, that sort of 46 mil in July, 46 in August, that was really critical setup for the El Nino. And often you look at El Nino years, there's often a month in there where there's basically a single digit rainfall. And yeah, I think, you know, some places that had good soil moisture last year dodged that bullet. Now here we go, Indian Ocean dipole, effect on Gawler's rainfall. When the IOD is sending us less moisture, sort of drier in these parts, and you can see here in those previous events the effect on August-October rainfall, a bit more chance of drier, still a chance of getting some average or better. And in IOD negative years, when the IOD is turning the taps on, quite a strong influence here where you know, 2/3 of those years were decile 8, 9, 10. Still the odd one that was dry, but it's interesting. I know a lot of farmers say, well, these odds don't guarantee anything really, so I'm not sure if this stuff's useful or not. And I guess one way to look at it is that, well, imagine these are two different poker machines, and you're a farmer, you've got $1 million to invest in a poker machine, and you're needing either a blue or a yellow to get a payout. Would you like to know which machine had these odds and which machine had these odds? And basically that's about as good as the seasonal forecasts are, is just letting you know in any particular spring which sort of one. Are we in a spring with you know, perhaps a higher chance of extra moisture or a higher chance of you know, decile 1 to 3. It's just useful to know that. Doesn't guarantee it happens, but it's probably useful so you can start to plan out some potential finishes if things start to finish quick, or make the most of those years when, you know, there's more moisture around. And I guess one of the things too for seasonal forecasting, as much as we're in February now and everyone wants to know the forecast now, but unfortunately this time of year, early in the year, there's a bit of a predictability barrier, and basically the oceans are still setting themselves up. And the analogy I use is a bit like footy teams, and that our footy teams too are all hopeful, but really you get a much better guide, and your confidence in their form gets much better once the season kicks off and we get into sort of April, May, June, to get a heads up for that spring. So I've got friends who are very keen Tigers fans, and they are always very hopeful this time of the year, talking premierships and grand final dates. But as you know, it's a better guide to see how your team's travelling once you get to June, to see whether they're going to be top 4, top 8, or bottom 4. And that's the same for these oceans. So just bear in mind, any forecast this early in the year, there's plenty of changes that can happen yet, because those oceans are still setting up. And also what's informative is watching those changes as all of the climate seasonal forecast gets updated from month to month. And I guess that's where Dale Gray does a great job with DEDJTR's got a Fast Break newsletter, and it comes out. There's a YouTube version which you can look at on your phone or your computer, which is just a monthly 3 or 4 minute update, but there's also Fast Break table and a few other things there, which provides that commentary of Indian Ocean and what the El Nino's up to and all that sort of thing. It's for Victoria. It is free. It's just via email subscription, but a lot of that commentary around those broader drivers are pretty relevant for South Australians too. So one of the key questions people are asking us this year though is that, well, okay, so we know what's happening in previous El Nino years. What's happened in the year after previous El Ninos? Good question. Well, again, Dale's kindly thrown together this. These are the years, those El Nino years, but then these are the following years, and he's just looked at the April to October rainfall in the years following El Ninos at Gawler, and you can see how in El Nino years there was a lot more red there, whereas in the years following there's obviously a lot more decile 8, 9, 10 years or more years that are in that average range. So that's at least one little bit of hope. It doesn't guarantee it. You can obviously see there were a couple of years there where you know, in 2007 was one where, you know, it was a dry year, but fingers crossed the odds bounce our way this year. Now I want to just explain this. This is the fast break table that Dale Gray puts together, and it looks a bit complicated, but I'll explain it because I think it's a really good, a useful guide to get a quick heads up of how different global models are summing up. Now across the top here what we've got is 11 different global forecast models, so they're making predictions for, you know, the 3 months ahead, and also a 6 month ahead prediction as well. So here's the current in Feb, their predictions for March, April, May. This is for the European model. Here's the Australian Bureau's model, Japanese model, NCEP USA, NASA USA, Japan, UK model. So all of them are across there, and it's really interesting because to me it's a bit of a footy tipping sheet, and you can get a bit of an idea. They're saying, you know, okay, well, El Nino will be around for a while, but then here's their autumn rainfall forecast, and so it's interesting that at the moment there's currently 7 of these models of the 11 which have got a slightly wetter signal coming out for that autumn, which is, again, remember that it's a predictability's poor this time of year, but that's certainly you know, it's starting to say when more than one model starts to say there's a few of them starting to indicate that. You know, that gives us a bit of hope for the year ahead. And when it looks to those longer term forecasts, there's a couple there that also have a bit of extra moisture there. So this is going to be really important to watch these as it clicks over and we see the March model runs, to see as their skill level starts to get a bit better about how many of them. And to me, it's a bit like a footy tipping thing in that if only one of them tip something, then you know you've just got to you know, take that with a grain of salt. But if suddenly there's a few of them all picking up there's some particular changes in the ocean, that means for wetter or drier, then that's important to take note of. And probably, you know, when we're looking at this last August, September, there were a number of them that were starting to dial up the potential for drier springs. So a good little tip, and that this gets emailed out every month too. Dale's done this particularly for South Australia, just for the SANTFA conference. Normally we're just sort of doing that for Victoria. And I guess we've done a bit of a you know, when we look at what are those options when you're looking at these tables and these outlooks, but basically it's a bit like the Reserve Bank. You know, there's either some upside models suggesting that, or a bit of downside like last year, or nothing to look at this year, or they might be all over the place. That's about as simple as it is. So it's important, tap into a good source and of info, and it just a quick heads up as you're going through the year to see, well, again, might be only once every second or third year where there's a strong signal that's useful to. And we've done a bit of a Brownlow count at the end of each year, the last few years, and looking at these climate models and the forecasts, and then we've at the end of the year and gone back and see, well, which ones actually were their predictions pretty useful or on the money. And it's surprising how good the commentary of this stuff is. It doesn't guarantee anything, because often it comes down to some different individual events, but the broader story last year, you know, for Victoria, you know, where there's an El Nino, but there was a bit of a wrestle going on with the Indian Ocean dipole, but largely, you know, most of Western Victoria did end up with that dry year. So it was interesting in the 2010 year, even as early as March, quite a few of the climate models were starting to, you know, think there was going to be a wetter spring with that big La Nina, and we probably didn't believe them at the time because it's been so long since we'd seen a wet spring. But they were right that year, and they picked that one quite early. So again, this area is improving, and it's certainly worth keeping an eye on. Okay, so everything I've been talking about up to date has been around seasonal variability, and so what I'm going to talk about now is there anything different going on, perhaps than just variability, any curveballs. So I guess one of the main curveballs is this temperature trend. This is from the Bureau of Meteorology. It's for the last 100 years, and you can see temperatures going up and down, and often, you know, a couple of La Nina years is sort of cooler years, and El Nino years tend to be warmer, but there's a broader trend there for the last few decades. And if I gave this data to a bookmaker and said, what are the odds for the next decade, without knowing too much about climate science, they're probably just likely to say, well, the race favourite is for the current trend to continue. So we'll talk a little bit about why I think that might be happening. And I guess this is where we start to talk about carbon dioxide and good old-fashioned CO2, because I guess, and I probably shared the journey with a lot of others, it's saying, why are people so worried about CO2? It's something that we breathe out, it's not poisonous. Plants actually love it, and we know with some of our ag-face studies that you know, potential to really improve crop yield. So already actually elevated CO2 levels is helping with our crops and plants. So what's the big fuss? And I guess for me, I didn't appreciate the story about that goes back to the 1850s, and it was really around this broader story that some of the scientists at the time were noticing we get energy from the sun, and that energy hits the Earth's surface, and then, you know, that radiates heat. But once the sun sets, that heat that's come during the day all radiates back out into space. And so some of the scientists at the time were doing their sums, and they're saying, you know what, all of that heat that we get during the day, well, a certain amount should escape that night, and if it did, the world would be about 33 degrees colder. So they're saying there's something invisible in our atmosphere that's not letting all of that heat escape at night. So there was a search was on to try and find what was that, what was trapping heat. And I guess a scientist called John Tyndall in the 1850s, he started doing some testing to pass infrared radiation or heat through various gases of the atmosphere to see which ones trap heat and which ones let heat escape. And he said, well, I'll keep it simple. 98% of the atmosphere is nitrogen gas or oxygen gas, so I'll take out the other impurities and just test the nitrogen and oxygen. So he did that and had the nitrogen and oxygen pass the heat radiation through it, and the heat slipped straight through it. And so he thought, okay, well, I'll test these impurities, these other gases. And when he tested them and passed the heat through, they actually absorbed the heat and reflected the heat back. So that was sort of basically the physics. And when you think about it, it's pretty simple, because nitrogen gas and oxygen gas, which don't trap heat, their nitrogen is just N2, so it's two nitrogen atoms stuck together as a molecule, very simple molecule, and oxygen as O2, oxygen gas, is just two oxygen atoms stuck together, so two very simple molecule structures that don't trap any heat. But if you look at the other gases like CO2, CH4, which is methane, nitrous oxide, they're all they're more complex molecules, and so it's just those extra arms and legs and things which actually trap that heat radiation. So that's basically the story for why they trap heat, and that's been known for a long time. And I guess one of the other things was, how do we know it's not just solar variation? Because there is 11-year solar variations in energy coming from the sun. But one of the key things, and NASA scientists tell us that while things might be warming up in the inner atmosphere, in the outer atmosphere they're actually measuring cooling in the outer stratosphere. And they're saying, so what we're actually changing is the ratio of energy in versus energy out. And so the more greenhouse gases we put up there, we just subtly change that ratio of energy in, energy out. So I guess that's trapping extra heat energy is why they're very confident that those warming trends will continue. And I guess a simple analogy I like to use is just imagine two cars parked out in a sunny day. Both of them got dashboards, the sun's coming through windscreen, heating up the dashboards, then those dashboards start radiating heat. So imagine that one of the cars has the windows up and one of the cars has the windows down. And what's the difference between those two cars? Well, one of them will obviously would be a bit warmer when you open it up at the end of the day. And basically, while they're both getting the same amount of energy from the sun, what's happening is there is a different rate of energy that's allowed to leave the two cars. The one with the windows down lets the heat's escaping out, so there's energy in versus energy out. It's pretty well equal. Whereas if you're looking at the car with the windows up, energy in, and more of that heat's getting trapped. So the broader story for greenhouse gases is, the more of those heat trapping gases we put in the atmosphere, it's just slowly winding the windows up. So that's why there's a lot of effort to look at, well, how do we start minimising our emissions in the atmosphere, and a lot of great work happening on that. So we've got a YouTube link there which we'll put on the website, which tells that story. And I guess one of the key things in terms of how it turns up, this is South Australia temperature for spring going back the last 100 years. So again, that's the warmer, 1 or 2 degrees warmer than average, and you could see they didn't happen that often. But if you look at those last few years and look at those last 4 years, you've had basically springs that have been between 2 and 3 degrees warmer than the long-term average. Now that's basically getting month temperatures early, so October temperatures turning up in September. And of course that's the average for the whole 3 months of spring. So what's tending to happen is we're just getting some early bursts of summer turning up in an intensive week. So, and as the Bureau I know someone's explained that to me, that really largely we expect that we're in the process of sitting in an extra month of summer into our broader climate. So for winter growing crops, it just means that that sort of runway in the growing season perhaps is getting a little bit shorter and a bit bumpy for takeoffs and landings. And I guess, we were all very mindful of that sort of thing that happened, last October, that sort of heat that turned up. I mean, October was, over 6 degrees above average for the month, in these sort of areas. But, most of that damage happened in that first week of October. So that's pretty tough for our plants to contend with. And I guess more broadly in the climate models, while they expect that sort of warming trend, there's question marks about sort of how quickly and what sort of weather that turns up in. So we've still got a lot to understand about how that all unfolds. Now, I know farmers get say, had enough about the heat stuff, get back onto rainfall, Graeme, because one of those things about if we do have warmer springs, if we've got plenty of moisture, then actually they're terrific springs. We get great growth and extra warmth coming out of winter and plenty of moisture. We just get fantastic springs. So it's what's happening with rainfall. And I guess I sort of like this particular bit of work. It's from Sorrow and Bureau Modelling. There's 23 different climate models, but basically when they plug into these climate models, okay, the world's a bit warmer, the models then, this particular map is showing where the models happen to agree that a warmer world and areas will get more rainfall and precipitation. These colours are where models are sort of a bit split, and some say wetter and some say drier. And these models are where they're saying, well, in a warmer world, the models are agreeing these areas will get drier. So what I sort of noticed from that is that it's actually quite different, from Northern Australia to Southern Australia. That the Southern Australia's got a different sort of story. And largely the physics behind all of this is where they're talking about, in simple terms, the hottest part of the planet's at the equator. So if the planet warms a bit, basically the tropics expands a bit each side of the equator, and it pretty well nudges everything from the equator towards the poles, just pushes everything poleward. So you can imagine where a lot of the jet streams and things sit. They sit on a certain point along between the hottest part of the planet and the coldest part. So if you warm up the equator, the tropics expand and everything gets nudged along. So that's why the climate models and the physics of that is they expect that to, things shifting south to continue. What's interesting is if we look at especially this October, say April to October rainfall, so that's sort of cool season rainfall in Southern Australia. This is looking at the 97 to 2015, so that sort of 18-year period compared to the longer term record, and just saying that for a lot of Southern Australia that has been the driest sort of period of growing seasons in the record. And one of the things I guess to note is that it's those southern bits which is sort of what was expected from the climate models as things get warmer. And so the next question I normally ask is, well, why are the models thinking that? The story here. And I guess what's been unfolding in Climate Jog Ridgey is the one we've got to keep our eye on. This broader story here, this is just the pressure pattern from 1950s up to about 10 years ago, but there's this broader story of just the pressure pattern getting slightly stronger in parts of Southern Australia. There seems to me to be a bit of uncertainty about where the pressure might concentrate in Southern Australia. So in my mind it's not been explained, or it hasn't been explained to me where that might happen, and that's pretty important because certain parts of Southern Australia, you go to places like Esperance and their last 15 years has been really good, but other places have had a tougher time of it. And this is an interesting graph. This is basically of the pressure pattern since 1950. This is April to October pressure over the whole of the southern Australian region. And basically you can see that the pressure average for that sort of April to October goes up and down, and you can often see, say a 60, 67, 68 El Nino there, the 82 El Nino, the 97 one, 2006, and last year's one. That El Ninos is when there's a higher pressure over Australia. That's what the whole Southern Oscillation Index is all about. So El Ninos tend to create a higher pressure, and then La Nina is usually with that lower pressure. So you can see all that variation in there. But what's sort of interest is that since that big El Nino in 97, we haven't sort of returned to some of those sort of lower pressures that were there in those previous decades. And then last year's pretty significant El Nino just nudged some of that pressure into higher pressure territory. So that's sort of, while there's a lot of variability in there, that's just one of the things that's sort of just subtly changing, I guess, in terms of our variability, and it has an implication for perhaps some of that drier pattern and why they expect that to perhaps continue for the coming decades. And of course there's a few little surprises in there as well. I know one of the things was saying, well, things get warmer, at least we'll have less frosts. But some of the great work by CSIRO and others, and the work by GDC and our department, James Nuttall, looking at how well, actually incidents of late frosts, and it's because of that, clear sort of nights, high pressure systems. That droughty conditions sometimes in spring can be quite conducive to spring or late frost. So frost risk is still hanging around. And even last year, this is just some frost shelters at Horsham by James Nuttall doing work with GDC and our department. But before that October heat wave, 2 weeks before, there was a -degree frost. So there was still some, those plants there trying to deal with some frost in 1 minute, and then some sort of 39-degree temperatures a week or two later. So I guess that's part of what we're all trying to deal with, and having more robust systems and healthier soils and better genetics and all those things are all part of which help us adapt to that. So wise farmers tell me that, at any point in time, this is all we really know. We've got recent rainfall, soil, rain in the bank is really critical. And I think, the use of soil moisture probes, push probes and all of those sort of things is fantastic. And that's a really important measure, and we're getting a lot better at that. And really, for reading El Nino last year, that was a real difference for some people who even though they had an El Nino forecast, they had full soil profiles, and actually some parts in New South Wales had a great year, but other areas that had really entering the spring with dry, pretty dry soils, that just increases your risk there. So people played it pretty well. We've got that 7-day forecast, and then there'll be some sort of multi-week forecast coming out of the Bureau, and then there's sort of 1 month and 3 month and 6 months. So all those sort of things are there. And then there's that sort of broader pattern about, autumn breaks perhaps aren't as reliable as they used to be, and bumpy spring. So they're all part of the mix of where we find ourselves at the minute. But the good farmers tell me this, and you just got to focus on what you've got control over. And I think one of the great things, and we've heard talks today about from other farmers, just about the one fantastic thing is how farmers have control of their soil health. So how soils are set up to capture rainfall, improve soil structure, organic matter, to hold on to moisture, to allow roots to penetrate it, and that is such a fantastic adaptation that and it's amazing the improvements that we've seen already, and how that's helped some of the crops there last year. So these are all things that farmers are doing, and I think grain farmers do this as well as anyone. And while it's often there's a bit of a concern about the climate story, when you look back in the last 20 years of all of the climate wobbles we've had thrown at us, it's just amazing when you look at how grains farmers have advanced, and through use of all these modern technologies, improved genetics, but improved equipment and soil health. There's a lot of improved infrastructure that's been happening on farms. Improved communications, like it's amazing what we've got in our pockets now for these phones, and you can look at get rain radars and forecasts and all of that. So growth in sort of markets and improved business management for variable seasons, that's a really critical one, and that's for a lot of farmers to do it well, that's really critical. And it's all really about the key decisions you make in the good years that really set you up for when things get a bit tight. So I think there's a really positive story about, for all of the curveballs that have been thrown at farmers, how well they've done to tackle it. But I guess one of the challenges still is that we're sort of just starting in a period where they call it a non-stationary climate, so we'll need to keep on adapting, and that's why we'll need to be making sure we've got really good research and development, and really good sort of networking and groups, and learning 1 year as a time, as SANTFA does. And I guess just observations about whether it's through climate changes or changes in markets or technologies over the years. These are sort of all of the different changes that farmers have been making, and often there's these first decisions which are things that we tend to do on the run, and it's just that sort of general improvement that we do along the way. But then there's these big decisions, which is really something where, well, if you do change one particular aspect, it has a knock-on effect to other things, so it more starts to affect the system. So these are things which I think and I guess with a lot of the no-till, there's a lot of things there that people have done that about improving those systems and making investments in equipment and infrastructure to get better at what they do to deal with this sort of variability, and then the sort of toughest decisions right through the end. But I think these are the things that have always been there in agriculture and how we respond, and really it's all about there's always, everyone's got a brighter, happier future out there, and working towards it, and whether it's in doing what you do or trying to tackle different markets or shifting the balance of enterprise or look at value adding. There's just so many different options there. So that's a really good thing, and we're going to need plenty of that sort of innovation in future as well. So I hope that's been of use. There's just a few links that we use. If you're interested, the break, we can, that's the email. Send an email there, it's free, and you can get some of that commentary from Dale Gray, our agronomist, and really those large drivers on what the Indian Ocean dipole's up to, and El Nino, Southern Oscillation. Those things are just as relevant for South Australia as they are for Victoria. So give that a go, and good luck. Here's a few other links there which we'll add on the website. So thanks for the invite to speak today, and good luck everyone for the year ahead. And here's hoping this year's got a bit more moisture in it than certainly last year's. So good luck.